So far, we have discussed different macromolecules, how they're built and what they're built of. There are various processes like building, breaking down, or converting molecules that constantly happen in our bodies. And enzymes help us to control these transformations. But before we start talking about enzymes, we need to discuss the basics of the metabolism. Now, metabolism is a sum of chemical reactions that take place in an organism. These reactions, of course, do not occur in a random way. They are rather structured as chains of processes that interact with each other. And these chains are called metabolic pathways, where each step is catalyzed by a specific enzyme. Now, there are two types of metabolic pathways: catabolic and anabolic pathways. Catabolic pathways release energy by breaking down larger molecules into small ones. And conversely, anabolic pathways use and consume energy to build more complex molecules out of simpler ones. Going back to the individual reactions, we can say that any reaction can be either exergonic or endergonic. An exergonic reaction is the one that proceeds with a net release of free energy, and an endergonic reaction is the one that absorbs free energy. But what is free energy? Free energy, also known as Gibbs energy, is the portion of a system's energy that can perform work at a constant temperature and pressure. And we can use this equation to measure the change of free energy in a specific reaction, where delta H is the change in enthalpy, T is temperature, and delta S is the change in entropy. Enthalpy is the measure of total energy that is present in the system, and entropy is the measure of disorder in a thermodynamic system, which means that the higher degree of disorder in our system, the higher will be the entropy. So finally, if the delta G of our reaction is negative, this reaction will be called exergonic. And conversely, if the delta G of our reaction is positive, then the reaction will be endergonic. But what does it mean if delta G is positive or negative? Delta, if you didn't know, indicates the difference in values as a result of some change. And the way that we measure it is that we subtract the initial value from the final value. So if delta G is negative, this will mean that G1 is greater than G2. So the amount of free energy in the beginning of reaction in our system was greater than the final energy in our system. This means that some energy was lost during the reaction. And as I mentioned earlier, an exergonic reaction is the one that proceeds with the release of free energy. And conversely, if delta G is positive, this will mean that G2 is greater than G1, which means that during the reaction, some energy was absorbed. Another crucial thing that you need to remember is that an exergonic reaction can occur randomly, whereas an endergonic reaction can't. However, this doesn't mean that an exergonic reaction doesn't require enzymes. It just means that this reaction doesn't need any external energy to proceed. I think it is now the best time to discuss enzymes and the way they work. As I mentioned earlier, enzymes are proteins that act as biological catalysts by accelerating chemical reactions in our bodies. But how do they actually work? Well, a simple explanation here will be that an enzyme takes one or few molecules that we call substrates by forming an enzyme-substrate complex, then converts them into products and forms enzyme-product complex, and then releases them. But if we look deeper, we will see that every reaction, no matter if it's exergonic or endergonic, requires some energy to initiate this reaction. And this energy is called deactivation energy. Now, what is deactivation energy? Well, every chemical reaction between molecules requires both bond breaking and bond forming. And the energy that is required to bring the starting molecule into an unstable state and then to break this bond is exactly what we call deactivation energy. And this energy can be absorbed in the form of heat. But if we simply increase the temperature of the biological system, this will accelerate all the reactions, even the ones that we don't need. So the way that enzymes work is that they lower the activation energy barrier of a specific reaction that they catalyze. That is all for today, and I'll see you in the next one.